Hi guys, this is video 10.3 on our playlist, and it's about special cases of factoring. So one of our special cases of factoring is perfect squares. Now you can factor these just like we did our trinomials in our last lesson, but there is a shortcut if you recognize a pattern. So our perfect squares, we have a three-step model, so we can check to see if we can use a shortcut. Is the first term a perfect square? And if yes, then we check the constant, that number by itself. Is it a perfect square? And then lastly, the middle term has to be twice the product of the square root of the leading coefficient and the square root of the constant. Okay, so that's a lot of words. Let's look and see what that looks like, and it tells us how to factor here. Okay, so example number 1, we're checking to see if it's a perfect square and can we take a shortcut instead of using the x method. Okay, so first, our first term is 9x squared. Well, is 9 a square? Yes, it's 3 squared, 3 times 3, right? And then we're checking the constant, and it's x squared, so that's square too. Then we're checking our constant, 16. Well, 16 is 4 times 4, that's a square, right? 4 squared. And then last, we want to check this middle number. So all of our numbers have to have some kind of special thing about it in order to use this trick. So does that middle number, 24, equals 2 times what these squares are, 3 times 4? Okay, so 3 times 4 is 12. 12 times 2 is 24. Yes, it does. So we can factor it using our perfect square model. So the first thing we're going to do is take the square root of the first term, and this is the first term in your factor. Okay, so our square root of our first term, that's 3 times 3, it makes 9. So it's 3 squared. And then we also have an x squared. The square root of x squared is just x. And then we're going to take the square root of the last term. This is the last term in your factor. So our last term was 16. The square root of 16 is 4 because 4 squared is 16. And then we're going to use the middle sign in your factor. So the middle sign here, this one right here, in front of our middle term, is a positive. So this binomial is our factor. And then we're going to put it in parentheses and square it. Now remember, this squared, it means it's 3x plus 4 times 3x plus 4. And you can use the box method or the FOIL method, multiply that out, and check to see if you get this answer. So you're checking your work. 3 times 3 is 9. There's 2 x's. 4 times 3 is 12. There's 1 x here. 3 times 4 is 12. There's 1 x. 4 times 4 is 16. Bring out the 9x squared. Combine our like terms. We get 24x. And then bring out our positive 16. And as you can see, our answers match. So this is correct. All right, example number 2. We want to know, is this a perfect square? And if it is, we can factor it using our shortcut. So our first term is 1 squared. Well, yes, 1 times 1 is 1, so that's a perfect square. And the x is squared, so our first term is perfect squared. Is 25 a perfect square? Well, 25 is 5 times 5, or 5 squared, so yes. And then we're going to check our middle number. Does 10, we're going to ignore the plus or minus until we use it for our factor. Does 10 equal 2 times 1 times 5? 1 times 5 is 5, times 2 is 10. Yes, it's a perfect square. So to factor it, I'm going to put the 1x and then the 5. And my middle term is, my middle sign is going to be the sign in the factor. Put parentheses around it and square it. And there is my factors. All right, so special cases, this is just taking shortcuts from the X method. All right, so we can also have a difference of squares that we can factor. Difference of squares is going to look different from everything else that we factor because our first question here, is it a binomial? So everything we've factored so far is a trinomial. And difference of squares is the binomial that we can factor. And then it has to be a difference, so it has to have a minus in between those terms. And then our first term has to be a perfect square, and our constant has to be a perfect square. Okay, and then here's our steps to help us factor along the way. Okay, so example 1, is it a binomial? Well, yes, it's got 1, 2 terms. Check. Is it a difference or a minus? And yes, it is. And is 9x squared, our first term, a perfect square? Well, 3 times 3 is 9, right? And x squared is x times x. So 3x is the square root of 9x squared. And yes, it is. Okay, and is 16 a perfect square? Well, 16 is 4 times 4, or 4 squared. So yes, that's also true. With all of these are true, then we can factor. And here's our steps to factor. We're going to make 2 sets of parentheses. Put some spaces in there. Now take the square root of the first term, and it is the first term in both factors. So the square root of first term is at 3x there. 3x, I'm going to put it in both parentheses. Take the square root of the constant. Ignore the minus for now, and this is the constant in both factors. So the square root of 16 is 4 because 4 squared is 16. So 4 is the last term in both factors. Now one factor has a plus and the other has a minus. So we have 1 plus, 1 minus. And this is how you factor a difference of squares. That's your answer. All right, example number 2. It's a binomial. First, you always want to check to see, I forgot this step on the last one too. First, you always want to see if it has a GCF and you can factor it out. Our GCF of 1 and 49, that's always going to be a 1. So it really has no GCF to factor out. Okay, and then we're going to check to see if it's a binomial. That's 2 terms, yes. X squared and 49 are the 2 terms, so yes. Is it minus a difference? Yes. Is x squared a perfect square? Yes, x squared, it says it in its name, right? Is 49 a perfect square? Yes, 7 squared is 49. Okay, all of these are true, so then I can factor. I'll make 2 sets of parentheses. The square root of my first term is x, so it goes in both parentheses. The square root of my constant is 7, so it goes in both of my parentheses. Then I put a 1 plus and 1 a minus, and there's my factors. All right, guys, you have some activities to do down below these notes in your playlist. If you need help doing these, let me know. I will put the assignments up when I get them. So if you're ahead of me, just hang on tight and I'll get those out to you. All right, guys, have a great day.